have discussed how we can proceed with converting a regular expression to NFA, right? So now what we are doing is converting a finite automata to regular expression. That is, here we are dealing with the deterministic finite automata to a regular expression, right? So deterministic finite deterministic finite automata to a regular expression. How we can proceed with converting the deterministic finite automata to a regular expression, that is by means of Arden's theorem, right? So we are going to deal with the theorem, that is Arden's theorem. So using this theorem, we are going to proceed with converting the deterministic finite automata to a regular expression. All right. So here, please make a note of this statement. That's it, right? The proof is not required at this point of time. Just to make a note of it, right? So let P and Q be two regular expressions, right? So this is Adam's theorem, right? So P and Q be two regular expressions. If P does not contain null string, okay, that is epsilon is not there. So if P does not contain null string, then R is equal to Q plus RP has a unique solution, that is R is equal to QP star. Okay, so here, what we are going to try to proceed is we are going to try to come up with this particular equation of this form. Okay, if I am getting an equation of this format, then that equation will have only one solution. So please make a note. From this deterministic finite automata, we will be trying to come up to derive this equation, right? So if I'm able to derive this equation, then that equation will have only one solution of this form. Okay, of this form. That is, this is going to be a regular expression. Okay, so this is going to be a regular expression. Just to please make a note of it. It will be clear for you when we see example. Okay, we can start with. So this is a deterministic finite automata. So here what I'm going to do now is, here how many states are there? There are 4 states, right? Q1, Q2, Q3 and Q4 are the 4 states, right? So here what we are going to do now is, we are going to proceed with yes. So here we are going to proceed with finding equations. So how many equations will be derived? We'll be deriving 4 different equations, right? We'll be deriving 4 different equations. So please wait here. I'll be back. So here, how many states are there? 4 states are there. So here, in order to proceed with deriving the equation of this movement, I'll be using this deterministic finite automata. So using which I'll be deriving 4 different equations, because there are 4 different states, right? So what is my end target? I have to proceed with designing the regular expression. So which is the final state here? Q1 is the final state. So for this final state, whatever we are going to try to write the regular expression. So this is the acceptance state, right? So for that I'm going to try writing the regular expression. Okay. So here we can start. Here by writing the equation for each and every state, we will be considering only the incoming transitions. Okay, so here it will be clear when we see this example. So here the first equation is Q1. Okay, so first equation will be for state Q1. So Q1 is equal to, so what is the incoming transition? Incoming transition. This is the incoming transition. From where it is coming? From Q2. What is the input symbol? P. So Q2 V plus right? And what about the next incoming transition? Is there any incoming transition? Yes. So here it is. So what is it? Q3A, right? Q3A. So here, yes, here Q1 is a start state, right? Q1 is a start state. So this will be which comes from nowhere, right? So let me include epsilon. Okay, let me include epsilon. This is equation number 1. Okay, so this is state 1. So for that we derived an equation. Okay, let me number it as 1. Next I'm going to proceed with Q2. So Q2 is equal to, yes, so it is having one incoming edge which comes from Q1. Okay, Q1A. Q1A. So is there any incoming edge for Q1? No, right? So let me call this as true. Next is Q3. So what is Q3? Yes, for Q3, I'm getting an income wage from Q1, right? So B, so Q1B, right? Q1B. So that's it, right? That's it. This is equation number 3. And next is 4. So 4 is, so for the state. So what are the incoming edges? Yes, Q2A plus Q3B plus here, right? So here I'm having two invisible, A and B. So for A, Q4 plus B, Q4. Are you clear how we are writing the equation?
Yes, ma'am.
Yes.
Yes. Oh,
Ma'am,
let us
one
proceed.
doubt. In the first equation, epsilon, where did it come? Like, what's the
This is a start state, right? This is start
Yes,
state,
ma'am.
Q1
Yeah.
start state. So it is having an incoming edge which comes from nowhere. So it is epsilon, empty.
Okay. Yeah, thank you, ma'am.
So now we need the regular expression for this. So for all the final state, we will be trying to get the regular expression. So here, this is the final state. So for this, we are going to try getting the regular expression. Okay, so this is the regular expression. So here, when I can get the write the regular expression, so I can write the regular expression if this expression is in this format. Okay, so here you can see, so what is it? R1 is equal to Q plus RP. So no, it is not getting matched, right? It is not getting matched. So what I'm going to do is, so instead of, so I'm going to make use of these equations, other equations to make the appropriate multiplications, okay? So I'm going to update equation 1. So because for this equation only, I have to proceed with converting to regular expression because Q1 is the final state, right? Okay, so here Q1 is equal to, instead of Q2, I'm going to incorporate Q1. This one, right? Q1A. Q1AB plus, so instead of this Q3, I'm going to include this one, right? Q1BA plus epsilon, right? So now what I can do, so Q1 is equal to Q1 AB plus BA plus epsilon, isn't it? Right? So now what I can do is I'm going to compare this. I'm going to try comparing this with this one. Okay. So here you can see, yes, here Q1, here Q1, here R, right? So I can try mapping this equation with this, right? So okay, so here we can start with yes. So this can be considered as R, right? This can be considered as R. Similarly, here this can be considered as R, and this can be considered as P, and this can be considered as Q, right? Do you all agree with this?
Yes, ma'am.
Yes. So how can I write that? So Q1 is equal to epsilon Q. So here Q is nothing but epsilon. So that is epsilon. What is P here? P is nothing but AB plus A. So the regular expression is nothing but AB or A. Please make a note here. Already we have discussed. So here this OR operator can be represented by this or this or this. Okay. So these are the three operators which is used to represent the OR. Okay. So this is nothing but AB or BA star. Okay. So this is the regular expression, right? Okay. Now please do try writing the regular expression for this deterministic finite automata. Yes, ma'am.
Could you explain that the previous step? How did you get the second Q1 equation?
This one.
The one above that.
This one.
Yes, ma'am.
Yes, here I am having this equation, right? I am rewriting this equation with the help of equation number 2 and 3. So instead of Q2, I am having Q1. So what is Q2? Q2 is equal to Q1A and Q3 is equal to Q1B, right? So that is what we have replaced here. So instead of Q2, it is this expression we are using Q1A B plus, instead of Q3, I'm going to include this one. Q1 B A plus epsilon. Is that clear?
Yes, ma'am. Thank you.
Yes. Okay. Now what you're going to try do is you're going to proceed with the trying to derive the regular expression for this deterministic finite order. Please do try it out. I share this. Yes, I have shared it in the chat box. Have you completed? Finished, or do you have need some more time? Why, what happened?
I'm not able to use like only one equation I'm able to use.
Okay.
Yes, ma'am. Like the answers coming Q is equals to epsilon 0 star. Like that.
Yeah, clean closure of 0.
In closure of 0.
Yes. So what is the issue that? Okay, let us proceed. So here, how many states are there? 3 states are there. So I'm going to come up with the 3 different equations, right? So here Q1 is equal to
Epsilon plus Q1 0.
Q1 0 plus epsilon, right? Q1 0 plus epsilon. Next is Q2. Q2 is equal to
Q1 1 plus Q2 1.
Q2 1.
1.
Good. Q3 is equal to
Q2 0 plus Q3 0 plus Q1 Q2 0. Q3 0. Q3 1.
Yes. Yes. So here I need the regular expression for Q1 and Q2 because Q1 and Q2 are the final state, right? So I have to make Q1 and Q2 to map with this format. Okay. So here, yes, you can see, yes, this is matching. Do you agree with that? Q1 is equal to, so this is
Yes.
equation about 2, 3. Okay, let me take equation number 1. So Q1 is equal to Q1 0 plus epsilon. So this is R. I can map this to R. So this will be P and this will be Q, right?
Yes, ma'am.
So what will be the regular expression for Q1? It is nothing but Q P star.
Q
So what is Q here? Epsilon. So what is P here? 0.
0.
So it is equal to the enclosure of 0. So this is equation number 1. So next we have to proceed with the 2. Okay. So here 2. What is 2? So 2 is equal to Q2 is equal to Q. So Q1 1 plus Q2 1, right? So here I can replace this for Q1, I can replace this regular expression, right? So this can be rewritten as 0 star 1 plus Q2 1, right? So Q2 is equal to 0 star 1 plus Q2 1. So I'm going to try mapping with this equation. Yes, this is R, this is R, right? So this is Q and this is P, isn't it?
Yes, ma'am.
Yes. So we can write the equation as Q2 is equal to
0 star 1.
0 star 1.
1. 1 star.
0
That's right.
star 1,
1 star.
Yes, ma'am.
1 star, right? 0 star 1, 1 star, right? So next is going to be, so what we need there are 2 different final states, isn't it? Q1 and Q2. So we have to take the union of these 2. Okay, so we need Q1 plus Q2, right? So these 2 are final states. Final states. So we need this equation. So what is Q1? So Q1 is nothing but 0 star plus Q2 is nothing but 0 star 1 1 star. Right? So here what I can do, so here I can rewrite it as 0 star epsilon plus 1 star. That's equal to isn't it? Are you clear with this?
Yes,
Yes,
ma'am.
ma'am.
Yes, that's it. Okay. Okay, with regard to your what is that cat one? So the questions what we have dealt till this point when we asked. Okay, so on it is going to be similar to the topics handled in the class. The only thing is that the questions would be scenario based questions. Okay, so wherever the scenario based question is possible, already I have given you some sample questions in the class, right? You can get you have already got the idea with regard to this scenario based question that may be asked in this subject. Okay, so you please do work it out. If you have any queries, you please do ask me. Right, I have already given you so many, some questions, right? Have you all worked it or have you all completed it?
Yes, ma'am.
Yes, good. What about others, ma'am?
Yes, ma'am.
Yes,
Yes, ma'am.
good. Yes, ma'am. Good. So, do you have any queries with regard to the topics till this point, discussed till this point? Photos? How is it possible? Okay, let me stop sharing. I'll be giving you some other questions to work out with, right? Okay.